So essentially, a camera, what it does is you take a photo, and all it's doing is it's sending the light at whatever it is that you're taking a photo of, and bouncing it back, and it's collecting what that light is and interpreting it, and then reassembling it into an image. So what the internet does is very similar to that. All it's doing is taking information that you give it in a large amount, and it's saying, okay, we have to send it over a great distance via light, which is how fiber optics work. But initially, back in the day, if you go really far back, it was actually just through electricity, electronic signals. And it takes, a photo of me, let's say right now, our video, and it's saying, in Mike, in his face, we see, let's say, 3 million pixels. And we're going to break those all down, and we're going to identify them in ones and zeros. So it's pretty simple. That's how a computer works. It's all ones and zeros in a certain sequence that can be then reassembled on the other end. There's a great analogy that describes kind of how the internet works and how one thing goes from here to another place. So I'll get to that in 1 second. But essentially all the internet is exactly what it was initially called, which is a World Wide Web. It is a collection of different computer servers or devices that communicate with each other by some sort of a line, whereby you have a connection of either a copper cable or a fiber optic cable or some sort of radio signal, as we now have with our lovely cell phone devices. So when those things are communicating with each other, you could imagine, given how many devices we have and how many people are out there, it would get really confusing, right? Like everything would be trying to figure out, like, how do I know that this image and these bits, because, if I'm saying that my face is 3 million bits, well, there's how many of us? There's 15 people on this. So that's a factor of 15. And then you think about the billions of people that are using these technologies that you can't even fathom the number scale of how many bits of information that is. So what they developed was what's called an IP protocol. And all that is simply is that every single packet of information that gets sent has a stamp. And that stamp is defined by a very specific date and time, which is why the internet and people in technology have actually developed really, really, really precise clocks, because as we need more and more information being transferred, we need a way to identify that. And there's only so many numbers that can be thrown together logically that can be recognizable. So everyone has an IP address right now. I have an IP address that's assigned to me by my internet provider. The internet provider then looks at that IP address and says, okay, we know it came from here. Now we're sending it to Facebook, let's say. And then Facebook's going to look at that and say, okay, I see that's associated with this. I'm going to send back what it's requesting. And then that person is going to get what they requested from Facebook. And then they can simultaneously send something a different way and split out. It's a lot like a rail system or the mail system, if you think about it. Mm-hmm. How it does this is really interesting, and this is where the candy analogy comes in. What you do is you're baking a really intricate chocolate every time you send an internet request out somewhere. So you take a normal, I want to receive an email, so I'm going to log into Google. So you start making your candy with the, let's say, the Chewy Nougat Center. And then you start, exactly, chocolate is good, I agree. You start wrapping that nougat by sending it, and it goes through your ISP. What does your ISP do? It coats it in chocolate. Then your ISP sends it to Google, and Google says, okay, I'm going to add the wrapping on it, and now this candy is complete. Now when Google needs to figure out how to send it back to exactly you so that somebody else doesn't get your information, that nougat layer that is what you want, they unwrap the candy in the same way it was built. So you look at the wrapping and you say, oh, this wrapping goes to Rogers. That's a Rogers wrapping. So we're going to send it to Rogers. And then Rogers gets it and they say, oh, this chocolate layer is Mike's house. Okay, we're going to send it to Mike's house. And then I'm going to get it and I'm going to say, oh, this is the nougat I was looking for. So that's a very simplistic explanation, because in each of those steps, The way the internet has been built, it's actually quite large, and there are many, many layers. We're talking about millions and millions of layers in each individual candy. But that's for security. So you have different encryptions and things like that. So at the end of the day, the internet was created like this, but if you were, a layman person that's just using it and you don't understand how these things work, however would you be able to identify things by IP addresses and so forth, which are, hundreds of numbers long, the IP addresses are hundreds of numbers long. The IP addresses are about 10 to 20 digits long, depending on which type of IPv you're talking about. And then you go another layer, and then all the security protocols in there are more numbers. So it'd be near impossible. If you want to remember Google, for instance, how to get to Google to put it in your browser, it's like 10 digits, and it's not an easy to remember number. Juliana, your presentation is perfect before now. How hard was it for you to remember all of those numbers, right? That's exactly what the internet would be. So there's a guy named Tim Berners-Lee, who is considered the founder of the internet. And his idea was, we will create a protocol that recognizes this number and translates it into a word that we understand. And that's what's called hypertext protocol, which is HTTP, which is the beginning of everything that you see when you type into a browser. And that is how humans inherently surf the internet without actually doing it the way the computers like to see it. Because computers only understand the digits. They don't understand the words. So we had to create a code to translate that for us. So that's in a nutshell. By the way, if you understood that and keep that, you now know more than 90% of what internet users know. That is the top 10% of people understand that. And not even understand it, but simply know it and heard it and kept it. So know that now you are in the top 10 percentile of people who understand what the internet is.